Okay, so chapter 4, we're going to be talking about polynomials in this chapter, multiplying, dividing them, adding them, subtracting them, that kind of thing. So before we talk about polynomials, we need to talk about monomials. So mono just means one, so the mono part just means that we're looking at things with one term, right? So an expression with one term. So an example, 3x, 5m squared, or 7. So even though these have a couple different pieces to it, it is all in one term here, right? Uh, then a binomial is an expression with two terms. Again, the word by, the part of the word by means two. So here's a two-term expression, which is a binomial. And I'm sure you can guess what a trinomial is. Tri means three. So an expression with three terms. One, two, three. So three parts to it. A polynomial, poly just means many. So we're looking at things with many terms, more than one term. So any expression with one or more terms. Well, I guess one term technically is not a polynomial. So if it's two or more terms, as many terms, so it's a polynomial. So exponents and polynomials are whole numbers. So we'll look at that. Okay, like terms. We have the same variable raised to the same exponent. We simplify expressions with like terms by combining terms. So I think you first see like terms in grade 8 or grade 7, and we're just gonna, what like terms are is when you can put things together, different parts of the expression can be combined. So like variable a's can go with other a's. If it's a squared, then you have to find other a squares, etc. So we're gonna practice that down here. So circle and connect each of the like terms in the following groups and simplify and write your answer in the space provided. So you can see that here are all our terms, and now we're going to simplify them simply by clicking like terms or collecting like terms. You can do it a few different ways. I'm just going to underline the x's, right? X, x. So negative 5x and positive 12x. Actually, let's just do the cubed first. So we usually order from biggest to smallest. So I'll just put a little square around the cube so I kind of know where it is. There we go. So 5x and 3x cubed gives us, to combine together, gives us 8x cubed. Okay. Then we also have, and maybe I'll do a little heart here. You can do whatever you like, or you can just kind of remember what it is. So 11x and negative 3x squared will give us positive 8x squared. And then finally the two underlined plus 12 and minus 5 will give us positive 7x. And that's all it is. And I can go through all these. Maybe I'll go through one more and then I'll just write the answers for the other ones because it's pretty much exactly the same thing. So let's collect the biggest term, which I see is squared. So underline squared. Okay. You got negative 10y squared and you got positive 21y squared. Together you get 11y squared. And now we need to find the y's. So here's a y. Here's another y. Because they only have two like terms. So these three, they all have y's, so they're like terms. We can put them together. So negative 15 plus 3 is negative 12. Another is negative 6 gives you negative 18y squared. Oops, not squared. This one is just y. Okay, there you go. And you do the same thing for the others, and then you'll get negative 2ab. Again, if you want to combine ab, you have to find the expression with ab. So positive 3ab, negative 5ab. So that's we got negative 2ab. Okay. And then the a's, positive 4a, positive 3a. You get positive 7a. I said I wasn't going to do this, but might as well now. B's, there we go. 2b, 7b gives us 9b. Okay, good. Okay, I'm sure you can do the last one. So I'll just write out the answer, 3mn minus 7m. Okay, so let's look at a little bit about the simplify section. Okay, so this is going to be pretty similar. So you got your trinomial here, so a thing with three expression, and you also got another trinomial. So we're adding three trinomials, and we're not even multiplying anything. So you can basically drop these brackets and then just collect them exactly how we did here. Okay, so same sort of thing. So here, let's look at the biggest one that we have, the squares. So there's the 3x squared plus 9x squared will give us 12x squared. And then you got your x's. So there's an x here, 2x, and x gives us 3x. And finally, we're left with just the coefficient with no variable. So plus 4 plus 3 gives us plus 7, right? Okay, so let's just do one more here. So the biggest kind of uh, biggest term, I guess, with the highest coefficient would be the x squared. So negative 2x plus x squared plus 3x squared was gives us x squared. And then you also got the x's next, right? Negative 5x plus 2x gives us negative 3x. And then you just have a single coefficient, the digit, with no variable, plus 11. Okay, so that's all you're doing. I'm sure you can do the rest. We're just collecting them. Hopefully this is pretty simple and straightforward. Okay, I'll just write the answers out to save a bit of time here. Okay. Just checking if there's anything tricky, but no, they're the same thing. Just collect positive 4x squared. Oh, this one, I guess. Maybe I'll do this one here. So see, these ones are positives. So all we did was drop the brackets. This one, I just wrote the answer, but I'll show you here. So this negative here, it's like an invisible -1. Okay. And then what you do, basically it's -1 multiplied by this whole thing. So this negative, it goes on to each term, right? Like that. So this negative kind of bombs in, and then so -1 times 6x squared is negative 6x squared. -1 multiplied by negative 5x is positive 5x. And then -1 times positive 3 is negative 3. And then that's how now you combine this with the first trinomial, which you just drop the brackets. So you can see it's negative 6x squared, positive 4x squared, which is negative 2x squared. And then we got negative 3x, positive 5x, gives us positive 2x. Finally, negative 3, positive 1 is negative 2. So that's all you do there. Okay. Last little bit here. The degree of a polynomial is the highest sum of exponents of any one term in the polynomial. So we're looking at, so you get a question like, what is the degree of this term here? So, this expression here. And you can see that there's two terms. Okay. And then again, if there's no exponent on a variable, it's like an invisible 1. Okay. So you can see that there's 3 there, 2 there, and 1 there. So in the first term has a degree of 6. The second term has a degree of 2 and 2, which is 4. And then the degree of the whole expression is the biggest one. So the first one had 6, so that's why that degree is 6. So we'll look at some more examples here. So here we can see that here it's 5. 2 and 3 is 5. You got 2 and 1, which is 3. And then 1 and 1, which is 2. So the degree for this one will be the biggest one, which is 5. Okay. And you can do the same thing here. Kind of like maybe you could eyeball it. 4 and 2 is 6. This is less than 6, less than 6. So this one's 6. And here we can see that this is 3. This is 1 and 1 is 2. And his 1 and 3 is 4. So 4. 1 and 1 is 2. So I'll just write it down here. 1. And this is 1. Okay, so this degree, the biggest one, would be this one, 2. There we go. All right, so hopefully that's a quick review about what a monomial is, what a binomial is, trinomial, polynomial, collecting like terms, a little bit of kind of foiling, I guess, like multiplying the -1, then collecting like terms, and how to collect degrees. Okay, so let's move on to 4.1.